Hi, everyone. Welcome to hour 2 of talking. I'll try to go quickly. I got 60 slides. Let's see if we can do it. I'm Evan. I'm from Google. I worked on TypeScript. I work on some of these things. If you recognize those icons, I'd love to talk about them some other time. On the right, I got TypeScript there. I'm part of Google's TypeScript team. We're responsible for making TypeScript happen at Google, and it has happened at Google. But we've been working on it for approximately 4 years. To understand TypeScript at Google in general, I'd like to take a little bit to talk about JavaScript at Google, which is to give you a minor history lesson. Here are some dates and events that happened. 2004, Firefox 1.0 and Gmail. 2005, Google Maps. Google Calendar, around the same time as Internet Explorer 6, everyone's favorite web browser. Chrome in 2008, which led to V8. V8 led to Node.js. And then comes everything you've ever heard of related to web development. So you'll notice that TypeScript 1.0 came out when Gmail was roughly a decade old. There's 10 years of Gmail development that precedes TypeScript. And what that means is that Google has an artisanal tech stack related to JavaScript. And I'm going to talk about 3 pieces of that that are maybe relevant to you. And I'd like to emphasize, I don't mean for this to come across as like a sales pitch or nothing like that. I think for any engineering decision, it's critical to evaluate like its pros and its cons. Like there's good reasons to do things, there's bad reasons to do a thing. Some of the things we made are awesome, some of the things we made are not awesome. Hopefully these ones are slightly on the plus side rather than the negative side. I'll hopefully return to that theme. The first I'd like to talk about is Closure Compiler. Has anyone heard of Closure Compiler? Oh, it's pretty good. This is better than usual. Wow, I'm awesome. So the question that Closure Compiler is answering is how do you build a large JavaScript app, especially in 2004? Facebook made a system called Flow. Who's heard of Flow? I saw some talking about Flow. About the same as Closure Compiler. That's cool. I think you may have heard of TypeScript. Google has a system called Closure Compiler that is confusingly unrelated to the Clojure language with a J, and Clojure uses Closure Compiler, so it's even worse. Much like Flow and TypeScript, it is a thing where you put JS-doc annotations and it type checks your code. Here's a little snippet of Closure Compiler, just so you can understand what it looks like. It's all based on comments. It's kind of like Flow in the comments-only mode, if that's fair. The coolest thing about Closure Compiler is that it is an optimizing compiler. Apps like Gmail are incredibly large, so it takes your JavaScript code in and produces a smaller JavaScript program out. So here's the game. Will it optimize? What would a Closure Compiler do with this input code? This is a trick question. It already has the output displayed. The function is never called, so of course you're just not going to leave it out. OK, we call the function. Second trick question. You don't ever use the output of this function. Also deleted. So third try, we've got some output, which is that it looks at this entire program and produces console log of 12. So it follows the X through. Kind of inlining is a standard compiler optimization. And just to prove that it is not a console log optimizer, here's a larger program. This is a class with a constructor that has a member, and then there's a function call, and then it does them conditionally, and then it creates the class, and then it calls the method. And the output is, unfortunately, also console log. But actually, the compiler successfully analyzed this code flow.
This is like, in 2004, this was like not even on the radar.
In 2004, this was not on the radar, was the comment from the audience. Yes, that's right. In 2004, I found a design doc from the era that said we should look into removing whitespace from our JavaScript, but the only program available is a Windows executable, and we cannot execute it on our Linux machines. So this is today's Closure Compiler, to be fair. Hopefully, I have, just to prove that I'm not lying, if you actually log the class itself, you can see some output here where it has produced a sort of minified version of the class. So that is the pitch for Closure. This is the downside, which is that making a programming language is really fun, and it turns out to be extremely hard. There are all this stuff around making a programming language that is not the stuff you get when you get your Dragon book out of a CS education. And it is things like documentation. Like that playground was super awesome, right? That's like a thing, and you need to hire a guy to make the playground. Making every editor in the world understand what your thing does. How popular is it in the real world? Can you hire people for it? And there's actually 2 stories that I really think are relevant here, which is killing off Wasabi. Has anyone heard of a Wasabi? This is the, I think it's Jolan Software / Stack Overflow. They had their own programming language for making websites. And then they made the post, and he was like widely mocked, which was like, why would you make your own programming language to make websites? You're crazy people. And then 5 years later, they're like, OK, now we have to like undo that decision because it turns out it was a mistake. Asana is another startup that had a language called Luna. They gave it up and actually adopted TypeScript. So I might take a step back and say, what do you use compilers and type systems for? And here's a list of things that I care about. Catching errors early, code maintenance over time, IDEs, minification, bundling, obfuscating. This is sort of like what Webpack, Uglify, all these tools do as a whole. And what we recognized is actually TypeScript nicely does the first half of these. TypeScript has a great user experience, and it carefully does not do any of the second half of things. There's no optimizations in TypeScript, with minor exceptions like const enum, you could argue, is a thing that sort of is about making your code smaller, which is a trivial detail. In any case, we use the time-tested formula, which is take thing A, shove it into thing B, question mark, and in the output you get the great user experience of TypeScript, the tiny output of Clojure compiler. This is a tool called Sickle, which is TypeScript to Clojure, TSCL. All of our tools have TSCL in the name. This is the first of a number of open source things I'm going to demonstrate, or I'm going to refer to. And at the end of the talk, I have a list of all these. You don't need to write any of them down if you're interested in them. Sickle works for us. We use it for our apps. It is finicky. There is a project on GitHub called TSCC where someone picked up Sickle and was like, hey, I'm going to make this usable by like rollup, whatever. I'm old. I don't understand any of your kids and your fancy JavaScript technologies. No, I'm kidding. But I mean, anyway, that's another one to look at. I think the lesson in terms of scale, which is the theme of my talk, is that apps only get larger over the time. The optimizing compiler gets more important as the apps get larger. Gmail had 15 years of code thrown at it. And the compiler in parallel has had years of optimizer tweaks for huge apps like Gmail. And a company like Google, where you get billions of hits per day on the search page, even 10 bytes matters a lot. And so people who care about this have cared a lot about making things smaller. That was section 1 of 3. Here's section 2. I'm going extremely fast. This is great. The Basal build system. Who's heard of Basal?
1.0 today.
Basal 1.0 today. Yeah. Congrats to them. So the question is, how do you build software? How do you have a bunch of source code, how do you run the compiler? And per usual, every company came up with their own solution. Google had a system called Blaze, and then a Googler left Google for Facebook and made a system called Buck because he missed Blaze. And then a different Googler left Google for Twitter and made a system called Pants because he missed Blaze. Google was like, okay, enough of that. We're going to open source Blaze, and it's called Basal. I don't know what the deal is there. It's an anagram. Anyway, it's Basal. I may say Blaze. It's instinctive to me. Same thing. It's just like an open source. There's a Hacker News thread. Basal 1.0 came out today, the open source one. There's a Hacker News thread about it. Someone's like, I think they might open source the system they use. It's the same system. Basal, Blaze, same thing. The key inside of Blaze, and you'll see this also in the other build systems, is that you break your larger program into a collection of libraries. So here I have some Basal code on the left, which is a TS library that declares a thing called my library that has some source code in it. And it depends on yet more code. And then you can build this library, and it builds just this code kind of in isolation. So on the right, I'm invoking Blaze on this library. This is, sorry, Basal. I've already messed up once. Invoking Basal on this library, and it compiles. You might notice in the output here, it says, hey, it built this code. It has built DTS files. It does not build JavaScript files. Who is familiar with DTS files? I guess you've talked about them and definitely typed, of course. OK. We critically rely on this interesting feature of TypeScript, which is called TSC declaration. On the left, you have some input code, home.ts, that does a bunch of stuff. If you run TypeScript in this TSC declaration mode, it generates the thing on the right, which is a DTS file corresponding to the input. So the thing on the left is the code that you actually run. The thing on the right is like the API shape of this code, right? This is not for like publishing to NPM or anything. This is just like, given this program, what do things who use this module care about? If someone imports from this module, this function load CSS is not exported, so no one can refer to it anyway. So on the right side is sort of like the public API of this module. And with this, we are able to compile pieces of the program separately from one another. So here's like a diagram of like a hypothetical Basal app. Hopefully the text is small enough to see. There's a bunch of code, and there's dependencies between the code, right? Like, so on the left, you have your utils library, which is always like the innermost thing that doesn't depend on anything. But you might have, a home screen that depends on utils. You might have a settings screen that also depends on utils. Basal's cool feature is that it lets you mix programming languages. So, if you have like a Go program that generates code that's then fed into JavaScript and so on, you can plug all that into this large chain of dependencies between things. So I have a picture here of an API generator that maybe takes an API, generates some TypeScript code, which is then consumed by this thing. And this, I'm sorry, what's the question?
Oh, just wow.
Oh, yeah. This is, it's like a standard build system trick, I would say, maybe. I would say at the end, we top out in some sort of JS binary. This is like the equivalent of like your Webpack bundler or whatever. So you say, hey, I've got a bundle that depends on the app, which depends on so on, so on, and so on. And so the key thing of Blaze is we do each of these steps separately. And as a, yes, there's a question.
Do you mind elaborating a little bit more?
Yeah.
Just about the, how these things relate?
How these things relate.
Yeah, and how, like, if you were to add, say, a different programming language, how you would add it. Yeah, just.
Yeah, the question was how do you connect different programming languages in Basal?
Webpack, right?
Yeah, I'm sorry. It's a lot of these systems are very oriented around like Webpack. You make a config file that sort of says everything you're ever going to need to do. And I'll talk about later, for the size of Google's code base, we can't have like a central file. So Blaze is distributed across multiple files. So these might be different directories, for example. You're sort of like, in this directory I have the settings code. By the way, the settings code depends on utils.
Right.
So you might have an API generator here that generates JavaScript in some other code. So here I sort of fudged it a bit and made it pretend as if it was all one directory. But you might imagine these are multiple directories.
Okay.
I'm not sure that answers your question.
Yeah,
but
yeah.
okay.
Of course. Yes, thank you so much.
Basil is well documented outside of my terrible introduction here. I don't mean to, yeah, please.
Yeah, I am not familiar with Basal, but I am a little bit familiar with GN.
GN, yes.
It looks like that, except for like no curly braces, but like some braces, right? But GN ultimately it knows about the programming language you're using, which is really annoying. And I wonder, is it true for Basal too, or for?
The question is, does it know about the programming language you're using?
Yeah, ultimately it's for C++,
right?
And everything else is like a secondary.
Everything else is secondary. So GN is the build system used by Chrome and nothing
Chrome,
else.
I guess.
Yeah, basically. So it's very targeted to Chrome. I think they actually published a document about how they're interested in adopting TypeScript, and there's sort of some head scratching about like, uh-oh, what do we do now that it's not C++? Yes, I would say this is a standard build system trick. I may just, sorry, I don't know if I answered your question.
Yeah, so the question is this is for TypeScript or for
Right.
JavaScript stuff.
Correct.
Basal, okay.
No, sorry, Basal is language agnostic. So in Basal there is a thing called TS library, which is for TypeScript libraries.
Okay.
But there is also a Java library and a C++ library and so on. It sort of puts them all in a level playing field, if that makes sense.
Okay.
It's really common that you have your back end and your front end kind of in one project. Did that answer it?
No,
Kind
but
of.
we'll talk later.
I'm sorry. Yeah, I didn't mean to go into like the cross language thing of Basal too much. Pretend it's TypeScript only for now. That makes it all the same. I wanted to talk about one insight we had in how Basal works, because in Basal these are each separate invocations of the compiler. Normally you're sort of like, hey, I'm going to run TypeScript. It's going to compile my whole app. For us, we're going to build utils once, then we're going to build home, then we're going to build settings, then we're going to build app, and you sort of build them in the order that the dependencies demand. So imagine I took this same program and I changed the return type of home. This is the same program I had before. Home returned like a DOM element or whatever, but I changed it, so I made it in bold here. It returns a string. So the type definition of home now says, hey, I return a string. I changed the program. So you say, hey, build my app, and I've highlighted the things in red. It's like, hey, well, home changed, I got to rebuild that. App uses home, so I got to rebuild that. And the whole thing depends on all of my code, so I got to rebuild that. So Basal is about incremental builds, which is to say we don't need to rebuild all this other code because it hasn't changed because of the change I just demonstrated here. I just changed like one function to one file, and it knows exactly which things need to rebuild based on that. And the one cool thing that we do in Blaze is here's a second change to this function. And here I just added like an inner text write, some other effects that actually didn't change the API shape of this code. So the code has new behavior. The API of the code hasn't changed. And here, highlighted in red, when I say, hey, build my app again, it rebuilds this one piece of the app, but it knows it doesn't need to build things that use it because the API hasn't changed. So for each thing, we extract the API that it exports, and then things that are downstream of it can only rebuild or not rebuild based on whether the API changed or not. That was a lot of detail. I'm sorry. All of this comes from the ecosystem of Google where they have extremely large builds. Basal's oriented around extremely large builds. So with these separable libraries, we are able to build them like remotely, for example, in the cloud. If two engineers build the same library at the same time, they can like reuse the build output. There's a shared cache. This is a screenshot, sort of, from like a real app we built where there's 45,000 of these. And that's some enormous dependency graph where everything's running in parallel, if that makes sense. The key inside of this is that any build you do is proportional to the size of the code you changed, not the size of the entire app. So if you only change one module, you rebuild that module and sort of the minimal number of things that depend on that module. This also open source, the Basal build rules for TypeScript. It has a lot of caveats. They're documented in their repo. The final section in the rantiest section of my talk is talking about maintaining a large TypeScript code base. I posted some feedback to the GitHub tracker of TypeScript about TypeScript 3.5 that someone may have seen. Someone would. Oh yeah, the TypeScript team liked it. We have a very large TypeScript code base, and so we are very interested in keeping the large TypeScript code base alive. And in particular, to understand why we, the TypeScript team, care about this rather than individual apps, I'd like to talk about monorepos. Is monorepo a familiar term? I see some nodding. OK. At Google, all of the code is in one repository. It is, as of 2016, the public number. It has 1 billion source files, 86 terabytes of history. It's madness. It has a lot of upsides, has a lot of downsides. I see some head shaking. I agree with head shaking. I also would say that all of engineering is trade-offs, and so there are pluses and minuses. The minuses are obvious. Some of the pluses, to use code from another project, you can just put it in your deps. I was showing deps there. You know, I'm in Gmail, and I'm like, hey, I got to use this code from calendar. I'm just like, deps equals code in calendar. Everything continues to work. Is us. That is why we have a TypeScript team. The actual TypeScript team, the real TypeScript team, is responsible for making TypeScript better. We're responsible for keeping it alive. TypeScript cascades are kind of like this. Anders comes into the GitHub tracker and says, we're going to improve our constraints over non-homomorphic map types. You might know what this means, you might not know what this means. What this mostly means is that the rules are changing. It's great. Anders is great. We love all of the type system changes he makes. I do mean that. I don't mean it sarcastically. But in practice, what it means for us oftentimes is that code that was previously working is broken. Generally, frequently, code that was actually wrong. So it was like, oh, hey, thanks. You found a bug. So what do you do with an extremely large code base where suddenly you've noticed that half of it has problems? And I'd like to talk again about a thing that maybe involves raising hands. Who is familiar with the pets versus cattle analogy for server management? I see some chuckling. I'm not responsible for this. I worked on like a Web 1.0 app in the 90s. And back then, you treated servers like pets, which is to say you had a server, you gave it a unique name. If there was downtime on that server, it was a tragedy. You needed to come in on the weekend. The individuality of a server was cherished. We had the database server. There's problems with the database server. It's an important thing. I would say the modern world has shifted to a cattle-like attitude, which is all you care about your servers is how many you got. If one of them fails, you shoot it in the head and bring over another one. Forgive me, this is unkind to animals. It's just a metaphor. And in fact, the important insight here is that the individuality of any given machine is a liability. Like if you're like, oh no, if machine 43 goes down, we're done for. You're in trouble, right? And I would like to say that this metaphor also applies to code, which is as the larger your code base gets, the more individuality hurts. Over here we do this thing with this one weird library. Now it's like, okay, now every time we touch anything, we have to worry about what over here does. So in the Google environment, because of the quantity of code we have, we treat our code like cattle. So there's no custom build or test steps. It's only ever Blaze. Like if you have a test that doesn't use Blaze, then your tests don't get run. You don't get any choice in your TS config options. There's one set that we control. There's no choice in code style, which I'll get to in a second, I guess. At a small scale, when something breaks, we can fix all the code by hand. And at a large scale, you actually can no longer do that. You need to write programs that transform code. Here is a picture of some source code that is maybe a little bit hard to read. It's not super important, but with strict function types change in TypeScript, it again was code that was previously illegal that became illegal. And what do you do with it? You take every time sometime a person used this down type thing, and you change it and add an extra line of code. And we use TypeScript code transformation functions to do this through TS-lint. We basically write a linter that's like, hey, you wrote this, we need to write this now, and then we auto apply it to everything in the code base. And a to-do to be like, hey, by the way, we went in and monkeyed with your code, and you should probably actually look at this and be like, why did TypeScript reject it? There's probably something going wrong here. To do automated code transformations like this, without people getting mad at you about where the semicolons are, we mandate, for example, white space rules are all the same across all code. We use a tool called Clang Format that formats TypeScript code. Prettier, who's heard of Prettier? Oh, I should just drop this. Everyone knows Prettier. Did anyone like Prettier or dislike? Yeah, Prettier is the popular one. It's too bad. It's another case of where we made one and it was actually fine, and then someone else made a different one, and it's just like randomly different. That's great. We should use Prettier. This is a thing in software. I feel like GoFumt is the Go one. Clang Format works for C and Java. Rust has one. It's like a thing. I think Go is the one that popularized it. If you'll forgive me for my one rant, I'm like really into auto formatting. This is my one takeaway, and like write down like, oh, I should really think about auto formatting my code, which is like, these auto formatters take your code and they just remove all decisions about like where the white space goes. And you never have to argue about it again. The most common objection to it is like, hey, but you know what if I like really put my white space in a great spot? This is a pets versus cattle thing. Like, we don't have time for your preferences. We are going, the machine is going to grind through your code and eat it. And like, this is a quote from the talk about Go, which is that the style that GoFumt generates, the Go team doesn't even like it. But everyone who uses Go, it's frequently the best thing about it. That people use Go and GoFumt, do they like it? I was like, this is crazy talk, and then I used it for a bit. I'm like, it's the most amazing thing. You don't even think about indenting anymore. You just like write code, and then when you hit save, it like puts all the tabs back in. So if you need to like wrap something with an if statement, you just put the if statement in, and you don't like carefully arrow down to like tab or whatever. You just like put it in, shows you what it is. To me, I feel this is like the unit test of the 2010s, which is like, you know, in the old days, people were like, why would I write unit tests? And now you're like, wait, you don't use unit tests. What's wrong with you? I feel like this is going to be like in 2020, they're going to be like, I can't believe you like made any progress without code formatters. I'm like a crazy person about this. I'd love to talk to you about it in person. If you want to argue with me, come at me. Okay, I'm almost done. So I would like to talk. The last thing is about how to safely upgrade code that you don't understand. So here's some code. X number is some function. And then Anders made it so some function no longer returns the number. So what do you do? What do you do? And the naive thing that we tried is you look at it and you kind of stroke your beard and you're like, well, it used to return a number, but now it's a string, and we're going to go in and kind of like, carefully adjust it. This scales poorly. You need to now work on all code everywhere. And so the correct thing to observe is that the previous code as written works for some version of works. Like it ran in the past and it will continue to run. And the important thing about TypeScript is that the output of TypeScript is always independent of the types in your program. So you can take a TypeScript program, take every type you have in it, and just remove it, and it's guaranteed that you'll get the same output. So because of that, it is always safe to monkey with the types. This is such a fundamental design decision in TypeScript that in the bug tracker, if you ask for something, you have a checkbox which is like, hey, by the way, does your feature require us to do something different based on types? And if the answer is yes, then they're like, well, I'm sorry, but you can't do that. This is a great feature. If I may plug my own blog, I wrote a little blog post about this. This is the key to becoming a TypeScript wizard, is that actually there's all these questions where like, hey, does TypeScript do X or Y? And you're like, well, because it can't do anything based on types, the answer is. It lets you, it is like the blue pill or the red pill of TypeScript.
Plug your own blog.
You plug my own blog. You can
Yeah,
type that in.
that's
Search for this. I think it'll come up as the first hit, hopefully. So here's the one fix that is always correct. Answer to the quiz. As any is always correct because the types never matter. Like, right? Like, in the worst case, you have produced a JavaScript program, right? Like a program where every single place you wrote any, that is what you had with JavaScript. Like, that is like, you're falling back to just the thing you already had, basically. This is a safe transformation, so you can apply it mechanically. In fact, what we do is during TypeScript upgrades, we introduce a type alias for any that is long and ugly. Any during TypeScript 2.4 migration. And we jam that everywhere in the code base. And then you jam that everywhere. And anytime someone looks at this code, they're like, what the heck is this? And they try to delete it, and then they get a type error. And then they're like, oh, I should myself, as an owner of this code, stroke my beard and fix it. On the right is a graph. It's not the best graph, but it's a collection of the existence of any during somethings in our code base over time. And what you can see is that we introduce them and people remove them. Mostly. It goes up and down. Files get copied. They asymptote, I would say. There's a lot of code that's basically just like, unloved, I would say here, right? Like it's working, like just don't mess with it, right? Like don't change its runtime behavior. There's a little nudge there on July that's like dark green. I think that was like we added 2 for, TypeScript 2.1 or something, and then undid them shortly afterwards. So we do remove them. Those are some horror stories about upgrading. I think these are useful tools to have like in the back of your mind. I think type independent output is like a really powerful idea in this IDI transformation. So if I may try to summarize what I was trying to say. Scale is always trade-offs. Today, Basal 1.0 was released, and Hacker News is full of haters and lovers, as it always is. Here's a quote from someone who had something very nice to say about our TypeScript build rules. Someone's like, should I use this? And you're like, I would evaluate it on an estimated cost-benefit basis. The benefit is build times. If you can quantify how much time, you can estimate how much time you would save. This is a very measured response, you know? You should always go into things and be like, well, what do I gain? What do I lose? In particular for us, TypeScript, which is static types, I think oftentimes at TypeScript meetups, people are like, I'm not really sure about TypeScript. For us, we think TypeScript's totally worth it. We love static types. We think it helps maintain large code bases. Obviously, there are downsides in that the compiler yells at you, and there's many upsides about bugs being caught. I feel bad that I just pasted this person's comment because I don't know who they are. Violating their right to own their comments. And then finally, I promised, here is the list of all the open source tools I mentioned beforehand. Claim format and Prettier are the auto formatters. I guess everyone knows Prettier now. Basal is the build system, 1.0 as of today. Rules TypeScript is the name for, that might be a typo. It might be rules node. TypeScript has support for Basal and Node. Basal has support for TypeScript and Node. Closure compiler is the JavaScript optimizer I mentioned. Sickle is our weird thing that glues those two things together. Kythe is the code cross-reference tool. Thank you for listening. I would be happy to take a question.
So are project references leveraged by Basal at all, or is it just totally independent?
Project references post-dates our work on Basal. So
Right.
we're unaware.
There's been no integration.
No integration. It's a very similar idea, I think.
Yes, very. Probably inspired by.
Possibly. I'm not sure. Actually, I would say that this whole DTS thing, like in Basal, they actually do a similar thing with Java. Like it's kind of a, actually in the Chrome build system, they do a similar thing with C++ shared objects. So it's actually like a pretty, like extract the API and only rebuild if the API changes. So it's like a,
Module spec.
Those are
Yeah.
D files.
the DTS files, yeah.
It's called .d. It's just like whatever files you depend on.
Right.
I know what you're talking about, but no, I'm talking about something different. I'll talk to you about it separately. Yeah, you can extract the public API of a .so using like ELF tools, and Chrome uses that as a part of its build. Yes.
How strict is your one single TS config file?
How strict? Yeah. We do any and all strict flags that we can make work.
What didn't work?
Oh my gosh. The oldest one is, I think, strict generic types because it broke RxJS in some fundamental way.
We got strict no checks in early though.
We got strict null checks, and strict null checks is like 80% of the win. My opinion is you should just do -- strict in TypeScript, like in general. It's what the team recommends. They're evaluating the pros and cons. Yes.
How do you come up with your code formatting rules?
How do you come up with the code formatting rules? That is a good question. There is a guy. He's German, so he really likes rules. No, we like Martin. I think the insight on formatting is that like it matters, but then it kind of doesn't matter. You know, as a programmer, you're like, this is my art, but I think like the art of it is actually in the like algorithms and product, and not kind of in like the layout. Is sort of how I feel about
I'm
it.
just more curious about how you get the consensus as a team. Is it like one
Right.
person who's rating them? Or?
Right. I find more value in having the decision made than in fighting about it. So generally, we have a person who gets to be the arbiter, and we have a discussion. And I'm like, well, I think here's what I would use to make the decision. Please let me know what you decide.
Yeah.
Pets versus cattle part.
I'm sorry.
I think you missed the pets versus cattle part.
Yeah, because he's the one person. Yeah. A claim format inherits a lot of its decisions from the other languages it supports, because it was originally written for C++ and Java. I guess the clang in it is the C++ thing. So there's a lot of like layout stuff that it knows sort of implicitly from that, about like where commas go and stuff. Prettier has totally different decisions. It's fine. I just really, if you're not comfortable with this already, I know, because I also was not comfortable with it, and then I became comfortable with it. This is my, yeah, you just gotta try the water. It's nice. Yes, sir.
Do you support
Oh.
across multiple repositories or just only single repositories?
Single repository. Rules TypeScript, the Basal support has something about cross-repository that I do not understand.
Okay, and then the second question, for your TypeScript migration system, is that part of Basal or is that a separate system?
TypeScript migration system.
Like, where you have the as any, which is the TypeScript 2.4
Right.
migration.
Inserting these things. No, that is a custom thing we did. It's basically like TSLint, which
2.4.
I know is deprecated now. Sadness. TSLint has a mode where it can apply the fixes it suggests automatically. So we create it like a lint, and then we like apply the suggested fix.
Are you gonna open source them or
Uh,
open source?
They are not open source. We really ought to do something there, probably. It ends up being very like specific to patterns in the
Is it
code.
Specific, like, or do you have like a generic, TypeScript? Here's like the 2.4 migration that's kind of like, maybe this is a question for also for the TypeScript team as well. But
Yeah. Well, like for example, in TypeScript 3.6, which we're working on, you can't write interface A extends window anymore because the type of window changed subtly, and we happened to be using this in many places. But the fix is easy. You do like blah as curly curly as window. Like you have to insert like an extra as cast, but it's very specific to this one thing. But writing a program to do it is like this long. So we have like a collection of like scripts like this. It's basically the same idea as like JS code shift, which we do not use, but I believe that is like industry standard. So you want to use JS code shift?
We just switched to TS Morph.
TS Morph. Okay, yeah, TS Morph is the other one. You, sir, had a question.
Oh yeah, this is a bit left field. I've been reading about like Dart, programming language.
Dart.
And I just find it interesting that you have there's a TypeScript team at
Uh-huh.
Google.
Yeah.
And Google has introduced Dart. From what I've read, it just seems like Dart is supposed to be the JavaScript.
The JavaScript
killer,
replacement.
the next,
Uh-huh.
or what Google envisions JavaScript should be, which is TypeScript in a sense, but more features of, I guess, like
Mhm.
a standard compile language. So, like, what's your take on that? Or, like,
Yeah.
like, how do I, like, would that work with Basal? Like, is there Dart to TypeScript to JavaScript transpilation? I don't know, it's just weird, right?
Yeah. I am not too familiar with Dart. I would say in general, like companies as big as Google are not monolithic. Like even adopting TypeScript was controversial within the company. There were a lot of people who had reasonable objections to it. And so there are many opinions about Dart as well. I guess is all I can really say on that without making someone mad.
100,000 employees.
It has, I'm sorry?
100,000 employees.
100,000 employees of Google. 100,000, yeah. So it's like, what does Google think about anything? Nobody knows.
Well, so follow up, because I think that was a really good question, and I heard agreement from these guys that they kind of thought that was a good question. Do you think that going and exploring with Dart is useful, that enough people use it to make it useful, or is it just...
I can't really comment either way on this one. I feel like anything I could say here will get me in trouble with someone, you know what I mean? Like, I feel like there's that guy Bob on the Dart team who has this amazing, he's written 2 amazing books. Have you seen Crafting Interpreters?
Yeah.
This guy, I have like a nerd crush on Bob. Like, so, I'm like rooting for all of them to succeed, but like,
Okay.
it's gonna be their own thing. It's not me.
Alright.
Can I propose maybe Dart is a way for Google to keep Lars Bach busy, so he doesn't do something amazing for a competitor?
Lars left Google like 6 months ago.
Oh, I didn't know that. But that 4 years. This,
Any TypeScript questions over here on the left? Yes, sir.
Does Basal deal with circular dependencies at all?
Basal does not allow circular dependencies.
I like that.
Right, so actually if you do have circular dependencies, which are allowed by TypeScript and ES modules, you have to put them in the same TS library.
But not by project references, so.
Yes. No, there's no project reference stuff. Yeah. Circular dependencies are their own type of problem. Yes?
What about hot module reloading? Does Basal help with that somehow?
Hot module reloading, no. People are talking about trying to do something there. It's very difficult to contribute to the JavaScript ecosystem without like stomping on something or making a thing that's incompatible with all the other things. Like in the world of bundling, there's like 15 options already. So we're thinking about it, but people are sort of trying to figure out a way to contribute there without just making another one that's incompatible with the other ones. I guess there's one more speaker. We have one more speaker here. Is that right? I want to just make sure I don't. Yeah, I don't make sure I don't like go into your time too much. So I think I'm going to cut it off there. I'll be at TISConf tomorrow. In the back, Rado with the beard and the hand up. Steve also with the beard and the hand up. And Jose without a beard but with a hand up. From Google. Come find any of us. We'd love to talk about any of this stuff. Thank you.